Hello everyone, my name is Vansh Panchal and this is my major project based on credit risk modeling, and this is provided to me by pregrad. Basically, the objective of this model is to predict whether a loan applicant is likely to default or repay the loan based on historical data. Basically, these type of models are used in banks, so I prepared these models using Python and machine learning models, etc.
I used pandas for database management and Seaborn and Matplotlib for visualization. And also I used train test split for splitting the data for different models and classification report for evaluation. I used a loan dataset named loan detection contain applicant information such as income, loan amount, credit history, employment status and other financial attributes, etc. Firstly, I performed the basic data analysis on this dataset. Here you can see the dataset has 41,188 rows and 60 columns. These are the columns that the dataset have. In this information, df.info will tell us that every column has how many rows and any if there is any null values and the data type of these values. One of the major issue in credit risk modeling is class imbalance. Here you can see our data is highly imbalanced. It is giving approximately 89:11. If 90% of the people repays the loan, a model can achieve 90% accuracy just by predicting repay for everyone, which is misleading. So to resolve this, I use the class weight balanced parameter. Automatically adjust inversely proportional to class frequencies. This ensures the model pay more attention to the minority class, which is defaulters. We will apply this during the fitting of our model. Then I have checked for the missing data. As you can see, there is no missing data in our dataset. So we do not have to make any changes in the dataset. Then I have checked for the duplicate data. If there is any duplicate data in our dataset, it will decrease the accuracy of the model, because on training with duplicate data, the model will not learn anything new. So we will remove all the duplicate data and only keeping the original dataset. As you can see, I have run the drop duplicate command, keeping the first value as it is and in place is equals to true. The in place function will permanently apply the changes to our dataset. Then I have checked for the outliers using the box plot. Here we have 60 columns. So putting all the columns in one box plot, that will not show much information to us. So we will plot the box plot for all the columns one by one, as you can see here. Basically, outliers are the data points that deviate significantly from the rest of the dataset, often caused by measurement errors, data entries mistakes, or rare genuine occurrences. The anomalies can severely skew model training, reducing accuracy and performance, particularly in linear models, though they may provide crucial insights in fraud detection. Then I have removed the outliers using the IQR method. Then again checking for the shape of the data. Our new data frame is this without outliers that have 38,771 rows and 60 columns. Then coming to the model building part, Firstly, I have my data frame, so I will separate the independent and dependent data from the data frame. Here I also removed some of the columns from our data frame that do not have much effect on the outcome. So I have removed this column using the drop command. Now you can see this is our independent column and this is our dependent column. Then I have splitted my data into train data and test data using train test split. Now this is my train data and this is my test data. Then I have used the standard scalar technique. Basically, this is a data processing technique used in machine learning to standardize features by removing the mean and scaling the data to unit variance. Then using this technique, I scaled my data. Now coming to the model fitting part, as you can see, I have used the logistic regression. I had chosen this because it is interpretable, widely used in financial risk modeling and provide probability output, useful for credit decision making. Then I have fitted my logistic regression model using my trained data that I have scaled using standard scaler. Now my data is fitted into the logistic regression. Then for checking, I have made some predictions from my model. As you can see, this is the original trained data and this is the prediction that my model have made. All the predictions are correct. Then also I have checked the accuracy of my model using the classification report. As you can see, the model is giving roughly 79% accuracy on the test data. Then I also use decision tree classification method. Basically, decision tree is a non-parametric supervised learning algorithm used for both classification and regression tasks. In decision tree, we have two methods to perform pre-pruning and post-pruning. In this model, I have used pre-pruning. Pre-pruning is also known as early stopping. It is a technique used in machine learning to halt the growth of decision tree during its construction phase. This prevents the tree from becoming overly complex and this helps to mitigate the problem of overfitting. Then I have imported grid search CV from the scikit-learn and passed all the parameters that used in the decision tree classification. As you can see, these are the best parameters that makes our model better. Using these parameters, I have fitted the decision tree classification model. Then coming to the model evaluation part. Again, you can see on the test data, the model is predicting accurately and basically it is a good score. Then this is the classification report of my model. It is giving roughly 85% accuracy on the trained data. And finally, I used one more method of classification which is known as gradient boosting. Basically, a gradient boosting classifier is a powerful ensemble machine learning algorithm that builds a strong classification models by subsequently combining multiple weak learners. It fits new models to minimize error residuals from previous stages using gradient descent, aiming to improve accuracy iteratively. Here I have fitted the model. Here we have two different types of prediction commands, that is predict and predict probe. This is the difference between the predict and the predict probe. Basically, predict is used to predict the actual class. For example, 0, 1, 2. Class value can be used when evaluation matrix is accuracy, recall, precision, etc. While predict probe is used to predict the class probabilities. 0.6, 0.2, 0.2 is the output of predict probe that simply denotes that the class probability for 0, 1, 2 are these respectively. Probabilities can be used when evaluation matrix is AUC, ROC, MSC, MAE, RMSC, etc. Here you can see after using the gradient boosting classifier, our accuracy is now 89%. Now the model can predict better. On coming to the conclusion, this project successfully demonstrates the development of machine learning model to predict loan defaults using classification techniques. I approached the problem systematically, starting from the data processing and feature scaling to handling class imbalance using the class weights in logistic regression. Instead of relying only on accuracy, I also evaluated the model precision, recall, F1 score, confusion matrix, ROC, AUC to ensure that the model aligns with the business objective, which is identifying potentially defaulters effectively. The model achieved good performance, showed stable results on unseen tests, indicating that generalize well and does not significantly overfit. The project strengthened my understanding of handling imbalanced dataset, selecting appropriate evaluation matrices, building interpreted model for financial applications, and implementing an end-to-end machine learning workflow. And that's all for my side. Thank you very much.